Visualization is a real challenge for us. Being typical engineers and scientists, we would build charts that have material classes and the types of experiments people do, and quickly the audience would get completely lost.
How do you explain what you're doing to an audience who does not do what you do?
We have huge data sets. You have so much information, it's hard to decide how to show it.
The design folks at MICA are naturally inclined to conveying complex information in very concise ways.
When HEMI came to MICA, it was somewhat of a surprise. Once I learned more about the commitment to interdisciplinary research and the imagination of that leadership, it seemed like a natural fit.
I never heard about a connection being made between an art school and an engineering school in the past.
To be honest, I was a little skeptical, and I think Jay was my first real interaction with an artist, to be honest.
Collaborations like this are always interesting. With HEMI, they didn't really have any preconceived idea on what exactly I would do. For them to even be open to that opportunity is really a rare treat.
In HEMI, we look at problems that are really complicated. In fact, the reason we look at them is because they're complex. They're difficult problems to solve, and there are things that you can't see. We spend time trying to see them. But then our problem after we've seen it is how do we explain that?
And that was really the goal in the end, was for me to tell stories. Extreme materials, it's such an unusual name to a lab. Picture big explosions and these enormous incidents, but what the lab really is in its extremity is very small. In the end, what it turned into was needing to build things that are sort of beyond into the absurd. So making a 90-foot accordion book to talk about something that happens in a fraction of a fraction of a fraction of a second.
The brilliance of that idea was you take the small sliver of time which is insignificant in our lives and turn it to something that you can see is significant.
And it gives you a sense of how there's this sort of long scale for this very short time period.
Just that way of translating the scales to something physical was really useful. And that book is really impressive.
I think the engineering side and the artistic side, they complement each other. If you don't have ideas, if you don't have imagination, probably you're going to be a bad scientist.
In the lab, we do scientific photography. We look at things at high speeds and we look at things at high resolutions. And so I realized that the photographer can actually give us a lot more input about how we can do our photography. I started being a little skeptic, but then I got really excited about it later on, yeah.
The world isn't set up in disciplines, and so the kind of questions about the world and materials in the world don't necessarily fall within disciplinary boundaries.
When you put the scientist and the engineer and the artist together, you can understand the problem, you can convey that understanding, and you can design a solution.